This video tutorial discusses the definition of geologic minerals, or we could say it another way, the geologic definition of minerals. So what you're expected to be able to do after working through this module and practicing on your own is to be able to describe the geological definition of a mineral, explain why volcanic glass, pearls, and cubic zirconia are not geological minerals, and identify criteria for why a mineral that's formed by biological processes is or is not considered a geological mineral. It turns out it depends on some characteristics. Okay, so we have a question for you here. We've got 4 examples of natural materials, and what we want to know is which of these is a geological mineral. Are any of them? Or maybe they all are, or some combination, or none of them. So take a few minutes, look back at any notes you have about the definition of a geological mineral, and see what you can come up with, and why. So there are 2 fundamental criteria that define a geological mineral. The first is that a mineral has a specific combination of atoms that are bonded together into a consistent pattern or in a consistent pattern. So what does this mean? Let's break it down a little bit. So when we say specific, we mean there's a set ratio. In this case, we're modifying combination of atoms with the word specific. So that means there's a specific or set ratio of each type of atom that is there. When we say combination of atoms, that is referring to the fact that minerals are solid objects because the atoms are strongly bonded together. And then when we say bonded together, we really are referring to the fact that atoms are bonded together in a consistent pattern, and they're arranged in repeated 3-dimensional configurations. So it's a very organized structure, and this is very specifically outlined or defined as something called a crystal or a crystalline structure. So minerals have to have a crystalline structure to be considered a mineral. Other substances can also have a crystalline structure. DNA has a crystal structure. For example, sugar has a crystalline structure, but it is not fitting some of the other definitions of a geological mineral, and so therefore it wouldn't work. But the fact that they have crystals, they both fit this criteria. So a mineral is a solid substance. It has a specific chemical composition. That is, there's always the same combination of atoms in that mineral, and they're in the same ratio. So think about the maybe most common mineral in our lives, or at least the one that we would come up with as being really common, halite or table salt. It is sodium and chlorine, and it always has that ratio of 1 sodium atom for every chlorine atom. So that is its specific chemical composition. So I guess I was getting a little ahead of myself because I wanted to use halite as an example. We've got 3 images of halite on the bottom here. We've got 2 examples on the left-hand side of models of what the internal crystalline structure of halite would look like. And then on the right-hand side, we've got basically a photograph of images of the table salt or halite that would be the kind of samples we'd have in class. And so for chemical composition, then, let's take a look at the next image. So for our example of halite, again, it's always sodium and chlorine bonded together in that same ratio of 1 of each atom in sort of a unit. It also has that internal crystalline or highly organized structure, and it's always repeating those atoms over and over in this pattern that looks like a square or a cube. So we would actually call that a cubic crystalline structure, but there are many different kinds of crystalline structures and shapes that will give crystals of minerals their distinctive pattern, their shape. So you have or you will be working with mineral physical properties. Those are the observations and tests you can do that help distinguish one mineral from another mineral. Those properties are a result of their specific chemical composition in their crystalline structure. And so when we say that these two criteria define a geological mineral, we also mean that, or it's important to consider also that the criteria mean that each mineral has distinctive physical properties. And that means it's got some unique combination of different physical properties, and that lets us identify it. So besides having that organized crystalline structure and a specific chemical composition as sort of our first criterion, the second criterion that defines a geological mineral is that minerals are formed by geologic processes. So let's talk about what that means as opposed to other kinds of processes. So geological processes are natural occurrences that cause geologic changes. So not the best definition in the world, but basically we're talking about natural processes that are chemical, usually in nature, and that can cause changes to some sort of geologic system. So we've talked about maybe some other processes like melting or evaporation and precipitation. These are all geologic processes that could be part of this system. So a question that comes up a lot of times is, can a mineral be formed by biological processes? So that is by something related to a living thing. Sometimes this is a tough question to answer. A mineral it's something we designate as a mineral, could have formed by biological processes, but usually we only consider it a mineral if that mineral can also form by non-biological geological processes. So it usually has to exist in a system that is not run just by organisms, by a chemical or abiotic system. But there are some things we would consider minerals that are made by biologic processes. So let me see if I can give you a couple of examples. It turns out that in your teeth, the mineral, the hard part of your tooth enamel, is fundamentally the same structure and composition, so it fits the definition or our first criterion for minerals, of a mineral called hydroxyapatite. And so I've got two images here. On the left-hand side, there's sort of like a hexagonal white crystal and a black background, and that is a geologic example of the mineral hydroxyapatite. So not in a tooth, but it can form in other sorts of environments. And then on the right is a special microscope, a scanning electron microscope image of somebody's tooth enamel, a human tooth enamel. So notice we're looking at this at very different scales, but it's got the same crystalline structure and it has the same composition. So we would say that hydroxyapatite either in your teeth or in a regular sort of geological mineral would be considered a mineral. Another example is calcite. Calcite is a mineral that's made up of carbon and oxygen and calcium, and it forms in seashells, it forms in other sorts of settings as well, so it forms in geologic settings. So it can form in these different ways, both biological and non-biological, or just chemical or geologic processes that occur naturally. So we would consider those to be minerals. The seashell or your tooth itself would not be considered a mineral because it has other components in it, but those particular minerals would be considered minerals. So things that are not minerals, that don't have an analog or another version of themselves that exist outside of biological processes. Pearls. Pearls are natural objects. They form by biological processes, though, and they do not form outside of artificial, human-induced processes for artificial pearls, or cultured pearls as they're called, or oysters that make pearls. There is, in some seashells, a really shiny, sort of iridescent color that happens, and that is a texture or substance called mother of pearl. And that is not considered to be a mineral because it doesn't exist in a geologic setting either. So a couple of examples of things that are considered minerals, even though they're also produced by biological living things, and then not minerals.